So in this lesson, we're going to take a look at ratios and proportions because you need to be able to know how to use ratios and proportions to solve a lot of problems in chemistry. So when we talk about a ratio, it's a comparison between two numbers, for example. Let's take a look at an example here. Here's a scenario. I like playing video games, and so for I get to play 2 hours video games for every hour of homework that I do. If I did 2 hours of homework, how many hours of video games could I play? Well, for every hour of homework, I get 2 hours of video games. So for the first hour, that's 2 hours. For the second hour, that's 2 hours. So I get to play 4 hours of video games. Or the way you could think about it is, if I write it like this, I could say I get 2 hours of video games. So two video games for every I'm going to put two dots there, colons, for every 1 hour of homework, HW. So there's different ways you can write a ratio. You can say, for example, 2 to 1 with the colon here. That means you get two game hours for every homework hour, for every one homework hour. You could write 2 game hours slash one homework hour. So that means you get 2 game hours for every one homework hour that you spend. Or you can just write it with words here, 2 game hours to one homework hour. Another way you can write this one here is 2 game hours for every one homework hour. And I'm just going to put video game or homework there just to abbreviate it if we're doing problems. So we can use the ratio like this, and we can use ratios like this, and set up proportions to solve problems. So for example, over here I have a similar scenario, but a bit different. I have Mr. Efrati gets to play 3 hours of video games for every hour of homework. So I'm just going to call this homework HW, and then hours of video games, I'm just going to call it VG, video games, like that. And so I'm going to make a ratio. I'm going to say that I get 3 video game hours for every one homework hour. I could have also written it like this: 3 VG, 3 video game hours for every one homework hour. And so I can use this ratio to solve problems. So for example, Mr. Efrati does 4 hours of homework. How many hours of video games can he play? Use proportions and ratios to solve this problem. So we want to find out how many hours of video games I can play. So I know that generally I can do 3 video game hours if I do 1 hour of homework, like that. And so I'm gonna equate this to the actual scenario. The actual scenario is that I did 4 homework hours. And so if I did 4 homework hours, what's my value going to be up here? How many video game hours, XVG, how many video game hours do I get to play? This X is what I'm looking for. So I really just need to solve for this variable. And so what you can do is essentially just cross multiply. I can send this value to the other side up here, and it becomes a multiplication. So I get X number of video game hours is equal to 3 VG, it's a unit, multiplied by, when you put them in brackets like this, it means multiplied by 4 homework, divided by 1 homework. Now notice we can do some unit calculation as we learned in the unit lesson. Homework over homework cancels out, and what we're left with is VG. So the X value is equal to 3 times 4, 12 video game hours. So you could have probably done that in your head. If I get 3 hours for every homework hour, you would have just done, well, 4 hours times 3 times 4 is 12. But this just goes to show you with more complex concepts, you can simply set up a ratio of proportions like this. Proportions, essentially, you're equating two ratios to each other. So this original ratio and then the actual scenario. And then you're able to find what the X value is. just by cross multiplying and solving for that x. So I get to play 12 hours of homework for the 12 hours of video games for the 4 hours of homework that I did. I don't actually play that many video games. I don't have the time, but if only, if only we all that time I could. Let's try another example. You can pause the video if you're comfortable and try the example yourself first, and then check your work. So one chocolate bar cost $3. Write a ratio for this scenario. So I'm just going to put 1 bar ratio 3.00. And I know dollars should come first, but I'm just going to put it at the end here just to treat it like a unit. So 1 bar is $3. You could have written it the other way around. 3 bars is $1. You could have done so for every 1 bar you get, it is $3.00. So 1 bar per dollar, or you could say 1 bar for every $3. Or another way to write this, and it doesn't matter which way you write it really. What really matters is how you use the ratio at the end of the day. But you could have also done, for example, $3.00 for every 1 bar. You could have done $3.00 per 1 bar like that. So understand this one's equivalent to that one and this one's equivalent to this one here. It also depends what I asked in the question. If I say write a ratio for the number of bars to dollars, you would have said 1 bar for $3. If I said for the number of dollars per bar, you would have said $3 per bar. So it depends on the way I ask the question as well. So let's use proportions to determine the cost of 6 chocolate bars. So we want to find the cost of the chocolate bars. And so usually what I do is if I want to find whatever I'm trying to find, I use my ratio so that the thing I'm trying to find is on top in the numerator. So for example, I'll use my original ratio, which was $3.00 for 1 bar. And in my actual scenario, I'm buying 6 bars of chocolate, so 6 bars. And I want to figure out, well, how many dollars is that? So X money. You could have done it the other way around as long as you're consistent. I could have done 1 bar over $3 is equal to 6 bars over X dollars and cross multiplied and found it anyways. It's just more work that way, but it would still come out to the same answer. So I'm going to cross multiply. I'm going to send this up here. And I'm going to get, so X dollars is equal to $3.00, put your units in there, times 6 bars over 1 bar. Numerator and denominator units cancel out, so I have a bar and bar canceled out. And then I get 6 times $3 left over, so my X is $18.00. And I can just put dollars back here. So it cost me $18 for 6 bars of chocolate because each bar of chocolate was $3. And you know how to do that in your head. And so if you know how to do that in your head, you can try to put that into a math sort of context. Because like I said, this will make things a lot easier for you when it comes to chemistry. And it'll allow you to cancel out units and know that you're on the right track with what you need to be doing. So $18 for 6 bars of chocolate. So let's do a few more problems together. And like I said, you can always pause the video and try it yourself and speed things up if you're really comfortable with this and you know the format that we're doing. For every $2 that you donate, 4 families get fed. So let's write a scenario for that, a ratio for that scenario. Let's do a ratio for number of families fed to cost. So we'll put number of families first and then cost after. So let's say for every 4 families can be fed for every $2. I'm putting dollars after just, again, because I want to treat it like units. So 4 families for every $2. Now, usually the practice is you try to reduce the ratio to simplify it as much as possible. So here I can divide both sides by 2. Divide by 2. And I get, so 2 families for every $1 that I donate. So I can feed 2 families for every $1 that I donate. And actually, that's what I've done. I did part B already. So I just reduced the terms. If you divide one side by 2, divide by the other side by 2 as well. And we get 2 families for every dollar that you donate. So now we can solve a problem using this simplified ratio here. We can use proportions and ratios to determine the cost of feeding 10 families. So again, we're looking for the cost. So we want to put the cost on top. Um, so another way to write this, like I said, is you could have done let's do the simplified version here. We could have done 2 families for every $1 spent. But now we're going to flip this because we want the cost on top. So an equivalent ratio, just using it the other way around, will be $1 feeds 2 families. And so I'm going to put that like that because I want to figure out cost. I want that to be on the top. You could have used it the way it was written here, and you would just have to cross multiply it, do a few more steps, but otherwise it would have been the same answer. And so we are feeding 10 families. So notice how we're consistent. Families on the bottom every time. 10 families. And we want to figure out what the cost of that is. So I can cross multiply, send it to the other side, and I get X dollars is equal to $1 times 10 families. I'm just going to put fam over 2 fam. Fam and fam cancel out. Dollars left over. So I have 1 times 10 divided by 2. That's going to be $5 to feed those 10 families, because every dollar that I spend can feed 2 families. And so I use ratios and proportions to solve that problem. Now we're going to take a look at this in a chemistry context, So what we've seen here is ratios and proportions, just kind of an everyday context in sort of real world examples that aren't related to chemistry. In the next video, we're going to go through a balanced equation and use coefficients to try to figure out to try to make ratios and proportions to solve problems that might be related to chemistry, because that's going to be the bulk of our unit coming up, and that'll be in the next video.